Hey everybody, this is Larry. This is day 24th of the Leetcode June Daily Challenge. Hit the like button, hit the subscribe button, join the Discord for chat, and let's get started. Unique binary search tree. Given n, how many structurally unique binary search trees that stores values 1 to n? Given 3, it's 5. Okay. So this is a very famous sequence. It is called a Karen sequence. I'll put it here. But and there are a couple of ways to do it. Some with combinatorics and stuff like that. But the way that I've remembered how to solve this is by just divide and conquer. So the way that I have it is that, okay, for each node on top, right, there are only how many ways are there to put nodes on the left, and how many ways are there to put nodes on the right? Well, for in this case, for n is equal to 3, you can either put 0 node on the left, 2 nodes on the right, 1 node on the left, 1 node on the right, and I forget which way I went, but 2 nodes on the left and 0 nodes on the right? So you kind of do that for every n, and then that is your recurrence. And then you can implement that similar to Fibonacci or something like that. It's pretty straightforward once you kind of get to divide and conquer, but it is a good practice in just thinking about how to break a problem down, and you can do it a couple of ways. Like I said, it's very similar to Fibonacci, but and there's actually a lot of math behind this. If you really want to get to know it, there are a lot of different problems that for this sequence that comes up. It's one of my favorite sequences, to be honest, because it comes up randomly all over the place. But yeah, but you can implement it in a few ways. I'm going to do it recursively with memorization. You could, again, because as I mentioned earlier, you solve it kind of similar to Fibonacci, and and then you could easily convert that to bottoms-up dynamic programming. I'll have a link below so that you could maybe figure out how to work that conversion. And yeah, let's get started on the code. So let's just say def of c of x. So what's that? So you use one node for the root, right? So then now you just have to figure out how many is on the left and how many is on the right. So let's have a for left in range of let's see, x should be okay, because this is exclusive, so you would never use x node on the left. You will always be just x minus 1 at most, because again, one of the node is root. And then right is equal to x minus left minus 1. Yeah. And then now, so you have a total. So then the total number of count is just the sum of all these possibilities, right? Because what we said was all the possibilities that you can do to enumerate it, and then just do it recursively. So total is equal to c of left times c of right. And then that's pretty much it. I mean, of course, it's not actually it, but it's pretty much it. And then now you can ask yourself, what's the base case? Well, base case is 0, you have 1, return 1. And yeah, and I think that's all you need. And now you can just return c of n. Though sometimes I think I may be off by 1, but yeah. Okay, and then now we could also just try out bigger numbers. And I also know that this, we didn't do the memorization part, but that's okay. Well, for now, this may time out. Probably will time out because kind of numbers go pretty quickly. But yeah, but it seems like we're heading in the right direction. And then now we just have to add memorization. Some of you at home might know that in Python there are libraries to help you with the memorization. I'm just going to put it in arrays to facilitate that. Let's just go, okay, cache is equal to, doesn't really matter, let's just say -1 times n plus 1. Why do I have n plus 1? Is because we want to store the value from 0 to n inclusive, and this n plus 1 numbers between 0 and n inclusive is calculated. say, is equal to force times also n plus 1 for the same reason. And then now we can do if is calculated of x, then we turn cache of x. And at the very end, we just make sure that we cache it. So cache of x is equal to total, and then is calculated x is equal to true. And that's pretty much all you need. And now, hopefully, this should be blazingly fast. Okay, well, maybe the test case is too big, apparently. It didn't give me the constraints I didn't know. But you can also see that it gave me a huge number, which I calculated very quickly anyway. But I don't. It goes pretty quickly, as you can imagine, as a kind of numbers, but I don't know how fast. Okay, so even 200 is too big. So, okay. I just wanted to try something like a big-ish number, so that we can see if we're correct. Okay. Well, apparently we could have even hard-coded the answer if we knew that it was going to be only less than 20. Even less than that. Okay. Well. Okay, so it looks okay, so I'm gonna submit. Maybe 0, but I think that's just the one case. So, cool. And of course, another technique that I would kind of talk about and think about is that, especially on a competitive programming, because on in an interview you can't really do this. But I would just actually, if for whatever reason this runs too slowly, and in this case it wouldn't, if it runs too slowly, I would just print out all the answers and then put it in an array and then just print it out with like an if statement or something like that kind of thing. But yeah, anyway, for an interview, this is divide and conquer at its very basic pretty much. So I would definitely be familiar with this, and calendar numbers is something that I'm a fan of. So so definitely just be familiar with it, and this recurrence also comes up a lot in dynamic programming problems. So not necessarily like this answer, but this sort of divide and conquer where okay, you now divide the left and then you divide the right and then you try to figure out how to kind of fit it in. This happens in dynamic programming a lot, so definitely practice it and get to be familiar with it. In terms of competitive programming, this is pretty straightforward. So yeah, I would definitely recommend studying up on this. Anyway, yeah, that's all I have for this problem. I think if you still have trouble with this, definitely just draw it out and visualize. But basically, the short thing is with these dynamic programming, especially with these combinatorics and sequence, try to figure out how you can represent a sequence by a smaller version of itself, which is easier said than done, I understand, but that'll let you kind of visualize it. In this case, we just start with, okay, we have n nodes. In this case, let's just say we have 5 nodes, right? Then we could enumerate, well, 1 node has to be on top, so we have 4 nodes to be on the left and the right, and that means that there's 0 nodes on the left, 4 on the right, and then it just keep on going down because they have to sum to 4 nodes, right? Something like that is the thing that you keep in mind, and that's the invariant if you want to call it that. But yeah, that's all for today. Hit the like button, hit the subscribe button, join the Discord and hang out, and I will see y'all tomorrow. Bye bye.